Right, so let's talk about ions. We know that an atom is electrically neutral. And we know that what that means is that we have the same number of protons and electrons. But an ion is a charged particle where they no longer have the same number of protons and electrons. And we have special names. Cation is a positive charge, and anion, the negative charge. So for something to react from the elemental or from the atomic state to become a cation means that in the course of that chemical reaction it has donated electrons to something else. They don't just sort of wander around by themselves or disappear. They have to go from one substance to another. So for a cation, it has more protons than electrons. And for anions, it has more electrons than protons. And so, if we think about our metals form cations. They react by donating one or more electrons. So if we look at something else, what metal will we choose? Do you want to pull out your periodic tables and have a look at them? And you might choose lithium. So that can be my representation of a lithium atom. I haven't gone into any detail in the nucleus, but I've got 3 protons in there. If it's, and it could have 4 neutrons, so it's lithium 7. And let's think about fluorine. So we'll do the same for fluorine. This is fluorine. That's the fluorine atom. Okay, so this one has got 9 electrons. We know that if we write out our electron configuration, this one would be 2, 1, and this would be 2, 7. Does that make sense? Yes? And when we think about valency, or this one has 1 valence electron. This has 7 valence electrons. Okay, because they're the electrons in the outer shell. But if we're talking about valency, this is how many bonds can it form, specifically with hydrogen. And so this has a valency of 1 because it can only form one bond. It's only got one electron to donate. So it then has a valency of 1. Fluorine has a valency of 1 because it's only got one spot to accept an electron into. So it can only form one bond as well. It's just that it forms its bond in a different way, by accepting or sharing rather than by donating. And in the case of lithium and fluorine coming together to form lithium fluoride, the way this reaction occurs is that the lithium atom is going to donate completely that electron in its valence electron to the fluorine, and what we now form the lithium ion, which has a positive charge, and we have the fluoride ion, okay, so this one's name is fluorine as the atom. As the ion, its name is fluoride. And they are held together because this lithium has a positive charge and the fluoride ion has a negative charge. They are held together by electrostatic force of attraction. Okay, it's just like the north and south poles of a magnet attract each other. The positive and negatively charged ions are also attracted to each other. These elements are very reactive. The lithium we know is going to be reactive as a group 1 metal, very easy, low energy required to donate one electron. Fluorine is also very reactive, whereas lithium fluoride is stable. Because they have both achieved noble gas configuration. So there's no gaps in their valence shell. Does that make sense? Now, if we look at our periodic table, this was a representation of the group 1 metal donating electrons. The same thing happens for group 2. So, and group 3, we're also going to consider that we don't really do a lot there besides aluminium, but we're going to say that they also react by donating electrons and end up forming a 3+ charge. So they're going to donate all of their valence electrons. Group 14 with carbon in it, that's a bit of a special case. Here with only 4, what do you do if you've got 4? Are you going to give them all away, or do you need to share with 4? Carbon shares. Okay, so carbon can form 4 bonds. And what it normally would do is share with another substance, and we'll look more at carbon later. But when we come across to the right-hand side of the periodic table, nitrogen, oxygen, fluorine, those groups 15, 16, 17, they are all similar to fluorine in that they are going to react by accepting or sharing electrons. So for nitrogen in group 15, where it, so if we think about nitrogen, nitrogen. See, it's got 1 pair of electrons, valence electrons, but it's got the potential to form 3 bonds. So it has a valency of 3.
I'll ask who makes the curve.
And the same then for oxygen. If we look at oxygen as representative of group 16, let's just have a nucleus. I'll keep going. The inner electrons don't do anything, they just stay there. So nothing's going to happen down there. But oxygen has 8 electrons, so we're going to have 6 in our outer shell. Means that it's got the potential to form 2 bonds, has a valency of 2. Does that make sense? So our metals react by donating electrons, and their valency is going to match the number of electrons they have in their outer shell. Whereas our non-metals will react by accepting or sharing electrons, and their valency is going to depend on how many bonds they can make to add up, add in electrons that add up to 8. And then for group 18, well, we're not reactive. Okay, the noble gas is just not reactive. Does anybody have any questions?
Is there any time that noble gases will exchange?